Solid principle is the design principle in object-oriented designing, and mostly software developed in object-oriented language follow the solid principle. Solid is the acronym for the five important design principles when doing the object-oriented programming. And these five important design principles are single responsibility principle, then we have the open for extension and close for modification principle. Then the third one is Liskov substitution principle, and the fourth one is interface segregation principle, and the last one is dependency inversion principle. So let's see one by one each of these principle in detail. Single responsibility principle states that every class must have only one reason to change it. In other words, every class must be responsible for a single purpose only. So let's try to understand this with the help of example. Consider you have one class that is an employee class, and in this employee class we have these many data members, that is ID of the employee, name, salary and the connections. And then here we have the two methods, that is calculate salary and save method. So this calculate salary will calculate the salary of that specific employees, and this save method will insert the detail of those employees into the database. So these are the two different methods that is present in this employee class. Now assume in a company different employee has a different designations, and as per the designation they land at the different income tax slab. So salary calculation structure will be different for different employees. So we can't generalize the salary structure in the employee class. So this calculate salary method should be present in the separate class, because in an organizations we have the different people and different people have the different designations, and corresponding to their designation they have the income tax calculations. So the same calculation cannot perform for all the employees. So that's why different employees have different tax slabs and different salary calculation. Similarly, in this same method, we are connecting from the DB like this driver manager or get connections, and then inserting the detail of the employee into this DB, that is the database operations. Now the problem here is, here we are creating connection from the DB and correspondingly enter all the details of this employee into the DB. Now DB operation happens multiple times in a project. Like you have a lot of operations are there where we perform the DB operations, and all the time we create the separate DB connections. So the fact is we can't create the DB connections all the time and return the data source, because the DB connection is a very costly operations. So for every entity, if we are trying to use the save operation and again create the connection all the time, then it is a very costly operations. So what we can do is, it's better to have a separate class which do the DB connections and return the data source for the insert query for this particular save operations. So we create a separate class to avoid the duplicate code of collecting the DB all the time. So let's say this is my separate class, that is a connection, and the responsibility of this class is to perform the connections and return the data source. And then this is my DAO layer. So this is the DAO layer of the employee class where we have the method save, and in this particular method we are passing the instance of the employee class, take the instance of this connection class, and then save all the details of the employee. So basically every class have its own responsibility and we separated out everything. And then this is my simple Pojo employee class where we just have the employee details like ID, name, salaries and all those things. And then for salary we create a interface. So this salary structure we take out from the employee class and create a separate interface, and the name of the interface is calculate salary, and here we have the method called calculate where we are passing the instance of the employee class. And then these are my two different classes which implements the calculate salary interface, which eventually implement this method calculates. So in an organizations there are different peoples have there, and most of the peoples have a different designations. So that's why according to the designations we are created a separate classes and calculate the salary accordingly. So the benefit of this design is any number of designation can be added in the organizations, and we don't need to change the employee code all the times. So what we do, we simply create a interface, instantiate that, and call the corresponding calculate method. So we have the calculate salary, which is an interface. We create the instance of it, and according to the requirement, we call the corresponding calculate method. So now every class has single responsibility. Open for extension and close for modification principle. So this OCP principle states that the classes must be open for extension and the close for modifications. So let's see an example. Consider you have one interface and the name of the interface is calculate operations, and this is my class addition which implements this interface, which is calculate operations. And now we have the constructor where we are passing the left and right and the result. So we perform the simple addition operation in this particular class which is implementing this interface. Then we have the subtraction class, and the subtraction class also implements this same interface, and this subtraction class also have the same operation that the addition has, like left, right, result as a data members. Then it also has the constructor which take the left and right arguments. So we have the subtractions and the additions, and then this is my class which perform the calculation by using this addition and subtraction class. So here we have the passing the instance of the calculation operation. This is the interface and we are passing the instance of it. So we can pass the instance of addition, we can pass the instance of subtractions because it's an interface. And now here we have the if else statement. If the operation is addition, we perform the addition. If the operation is subtraction, we perform the subtraction there. Now let's say tomorrow if new operation will come, like the multiplications or the division operations will come tomorrow, then we will add a separate if else statement here for multiplications as well as for the divisions. If you see, the problem with this type of implementation is all the time we need to change this code and add a else if statement for every new operations. But this principle states that the existing code should not be modified, so it should be closed for modification. How we can prevent this? So in this case, what we do is we create a separate interface, and the name of the interface is calculate operations, and here we have the method called perform. And then this is my class addition which implements this interface, that is calculate operations. So of course this class will implement this method which is perform. So we implemented this method perform where we are performing the addition operation. Similarly, let's say if we have the division operations, then we implement this interface again, and then we again perform the division operation in this particular method. So like that, we keep on adding the classes, and all the classes will implement this interface and they will do the job in the perform method. Now in this calculation class that we have so much of calculation here, but in this case we are simply passing the instance of the interface, and from that instance we are calling the perform. So basically, let's say if we want to do the calculation for the division, then we pass the instance of division in this operation because this is the instance of interface. So we can pass the instance of division, we can pass the instance of addition as well. So let's say if you want to perform the division, then we pass the instance of division here, and then correspondingly we call the perform method of division. Similarly, if we want to perform the addition, then we can simply pass the instance of addition here and it will call the perform method of the additions. So like that we can add as many operations as we want. So basically this code, this section of code is open for extension. It means we can add as many operations as we want, and our main class calculator will be unchanged because we are not performing any kind of operations here, but we can add as many classes as we want according to our requirement. So this is the open for extension and close for modification principle. Liskov substitution principle. So this LSP principle states that if derived is the subtype of the base, then the object of that type base may be replaced with the object of the type derived. What that means? Let's see with the help of example. Consider you have one class which is common bank account. And in this class, we have the variable called balance. This is my constructor. And then we have these methods that are present like deposit, cash out, get balance, and income. These are the methods that is present in this class, common bank account. And now let's say you want to create another entity. We call it payroll account. And this payroll account is extending this common bank account. It means it must have all the features of common bank account. But the problem is this payroll account doesn't find this method, that is income. So this payroll account doesn't have this method, and this class can't support this method. So how we can extend that? So what we can do is simply we take this class, override it, and return the exception that this particular method is not supported in this class. But the problem here is it is not satisfying the Liskov substitution principle because the subtype can't be replaced by the base type. The subtype is payroll account and the base is common bank account. So the subtype should always be replaceable by the base type. But in this case, we can't do that. So how we can achieve this substitution principle? Well, in this case, we will use the composition principle to satisfy the LSP property. So what we can do, we create a separate class and the class is account manager. And here we have these methods like deposit, cash out, get balance, and income. All these methods are present in this particular method. And then we have the common bank account. That was my common bank account. Now what we do in this particular class, we create the instance of this class, that is account manager. And now for all these required method, we are actually calling the method of this class. So here we are calling this dot manager dot deposit. So basically we are calling the deposit method of account manager. So in this specific class, we are creating the instance of account manager, and correspondingly for all those desired methods, we are calling the method of this account manager. Now let's say if we want to implement the payroll account, then rather than extending the common bank account, what we can do is simply create this account manager instance. This is a composition, and here by using this instance, one by one we start calling all the methods that are supported in this account manager. So in this particular payroll account, we don't support income. In that case, we don't require to call that method, and whichever method we required, we simply call it. So that's how we can able to achieve the Liskov substitution principle by using the composition.